All right, 63 says Juanita earned $35 for 3 hours of work. At that rate, how long would she have to work to earn $720? Okay, for this one, there's a number of different ways to do this one. I'm going to go ahead and use basic unit rate for this. So what that means is right here where it says Juanita earned $36 an hour for 3 hours, or $36 for 3 hours of work. I want to know how much she earned for 1 hour. Because if I know how much she earned for 1 hour, then I can go ahead and divide that by 720 to figure out how many hours she needs to work that to make that much money. So let's go ahead and do that. So $36, and that's 3 hours. So I'm going to divide it by 3 to find the unit rate. So that is 3 goes into 3 once, and 3 goes into 6 twice. And I'm done, left with no remainder. So that means that she's earning $12 an hour. So because she's earning $12 an hour, now I can go ahead and find out how long it's going to take her to earn $720 by dividing it. So 720 divided by $12. We know that 12 goes into 72 6 times. So 12 times 6 is 72. 0, 0, and 12 goes into 0 times. And we're out of room. So it looks like she's going to have to work 60 hours to make $720. Our correct answer is 720. Now for this one, we can go ahead and check it by multiplying $12 an hour times the amount of hours she worked, which is 60, and we should get 720 if we did it correctly. Let's go ahead and do this because it's always good to check your answers just to make sure you're getting them all right. So 700, look at that, 720. So I was right. The correct answer is C. 64. Whoa, 60. Whoa, that's not 64. There it is. 64. The distance a spring stretches varies directly with the force applied to it. If a 7-pound weight stretches a spring a distance of 24.5 inches, how far will a spring stretch if a 12-pound weight is applied? So here we have 7 pounds. So we have a little weight that is 7 pounds, and the little spring right here, it is 24.5 inches. It's stretched out. Now, if we're gonna put a bigger weight of 12, how far is this spring gonna stretch? Now, obviously, the weight is more, so we expect it to stretch out more. So right here where it says 3.14 and 19.5, why would the spring stretch out less if we're adding more weight? It doesn't make any sense. So we could easily eliminate those two answers right away. So once again, like we did a few problems back, I'm gonna go ahead and find the unit rate for this problem, which means if I'm using 7 pounds of weight and it's stretching 24.5 inches, then I want to find out how much it stretches for 1 pound. Because if I know how much it stretches for 1 pound, I can multiply that by 12 pounds right here, and I'll get my answer. So let's go ahead and divide 24.5 by 7. So 7 goes into 24 3 times. That gives us 21. And I'm going to bring up the decimal right here so I don't forget. 35 is what's left over. So 7 goes in 35 5 times. And that's it for that one. So for every pound that I add, so 1 pound, it's going to stretch 3.5 inches. I'm going to put the decimal right there. So now I know that the unit rate. So now I could go ahead and multiply the unit rate by 12. So let me go ahead and do that right now. I have 3.5 inches for every pound and multiply by 12 pounds. That's 0, carry the 1, 7, 5, and 3. It's 12. All right, so that's 4. So it looks like 420 pounds, that's not even on here. I see 42. Did I make a mistake? Oh, it looks like I did make a mistake. I forgot my decimal point. You guys should notice I'm always trying to trick you guys like that. So as you can see, it holds 1 decimal point here. So that means it holds 1 right there. 42 inches is the correct answer, C for 64. All right, 65 says Marissa's car gets an average of 28 miles per gallon of gas. She plans to drive 200 miles today and 220 miles tomorrow. How many gallons of gas should she expect to use in all? So we have this one's pretty hard problem to understand what we do here. The important thing is we're looking for how many gallons of gas she needs. So we know she gets 28 miles per the gallon. How many gallons does she need? I don't know. So we're going to put G for gallons. And it should be equal to 200 miles the first day and 220 miles the second day. In this problem, we kind of have to write an equation for this word problem. So in case you don't understand this, then go ahead and plug these numbers in to find out all the answers, to find out what the answer is going to be. But you guys should be able to write the equation for this and figure this out. So here we have 28 times G, which is the amount of gallons we need, and 200 plus 220 is 420. We're going to go ahead and divide this by 28. It's going to cancel out over here. 28 goes into 42 once. I've got to borrow this 3. 12 minus 8 is going to give us 4 and 1 over here, and then there's 0. And 28, I believe, goes into it. Let's see, 28 is close to 25, and I know that there's 4 quarters in a dollar, so that's 4 plus 2 more, or maybe just 1 more. So let's try 5. 28 times 5. I'm going to try 5 because I see it right over here. And that's going to give me, okay, what do you know, 140. So there we go. By doing that, I know that it looks like she needs 15 gallons of gas total to accomplish all the driving she'll be doing for those 2 days. So my correct answer for 65 is A. All right, question 66 says, Mr. Calloway needs to purchase enough grass seed to cover a 3,000 square foot lawn and a 4,200 square foot lawn. If 40 ounces of grass seed will cover 2,400 square foot lawn, how many ounces does he need to seed both lawns? So, all right, this one's kind of a tricky one. So we know that 40 ounces of seed will cover 2,400 square feet of lawn. So I'm going to go ahead and use cross product for this one. I don't know how many ounces he's going to need, so I'm going to go ahead and make that X. But I do know how much he wants to cover. He wants to cover 3,000 square foot of lawn and 4,200 square feet of lawn. So that together is going to give me 7,200 square feet. So as you know, with cross product, we go ahead and multiply these two right here. They're the only two we can multiply. So 7,200 multiplied by 40 is going to give me 0, 0, 0, 0. And 4 times 0 is 0, 8, and 28. So this gives me 288,000. So it looks like this gives me 288,000. And then I'm going to go ahead and take that answer and I'm going to divide it by what the only number I should have left, which is 2,400. Now, to a lot of you, this problem might seem very, very, very big. And it is a big problem. I erased half of that. Let me go ahead and fix that. It is a big problem, but it shouldn't be too difficult. I'm going to show you a little trick I use, and if you're in my class, you should already know this. So see how all these numbers end in zeros? So I'm going to go ahead and cut out as many zeros as I can from both of them. So I'm going to go ahead and cut out this one, just one, and then another one here, and then another one here. Now this one has a 0 right here in the box, but this one doesn't on the outside. My divisor doesn't, so I'm left with 24 divided by 2,880. So it helps me out a lot, and I'll still get the same answer. So 24 goes into 28 once, remainder of 4, and bring down the 8. 24 goes into 48 twice. 48 minus 48 is 0. Bring down my last 0. And 24 goes into 0. 0 times. So x equals 120. So it looks like I'm going to need 120 ounces of seed. My correct answer is C. 67 says, Mr. Ogata drove 276 miles from his house to Los Angeles. Oh, I wonder if he was going to see a Dodger game. At an average speed of 62 miles per hour. His trip home took 6.5 hours. How did his speed on the way home compare to his speed on the way to Los Angeles? All right, so for this one, I'm going to go ahead and draw a picture. Because sometimes if I look at the problem and if I draw a picture of it, it'll make a lot more sense. So Mr. Ogata drove 276 miles from home to Los Angeles. So that was 276 miles. And he was going 62 miles per hour. Now, it says on the way back home from Los Angeles, so going back home, he took 6.5 hours. Now, we know it's still 276 miles from LA back home. So the only thing is we need to find out how fast he was going. We know the time it took, but we don't know how fast he was going. So it took him 6.5 hours to do 276 miles. So all I really need to do here is divide it. So I'm going to divide 276 by 6.5 hours. Now, as you know, my divisor cannot be a decimal, so I need to move this over. It's going to be 65 now. So just erase that part right there. It's going to be 65, but what I do to the outside, I have to do to the inside. So I'm going to move that. I'm going to add a 0 right here. All right, so 65 goes into 28 0 times. It goes into 276. I believe it's going to be 4 times. Let's go and see if that makes sense. So 4 times 5 is 20. Carry the 2. 4 times 6 is 24. Plus 2 is 260. Okay, that was good. 160 dropped to 0. And 65 will go into 162 times. It's going to be 130 with a remainder of 30, but it's going to be a decimal, so I'm going to say it's he was going about 42 miles per hour. It's going to be a little more than that, 42 point something, but I'm going to say 42. So now I know he was going 62 miles an hour on the way to Los Angeles, and on the way back home he was going slower at 42 miles per hour. So it's asking me to compare his speed on the way to Los Angeles from it's asking me to compare how did his speed on the way home compared to his speed on the way to Los Angeles. So on the way home, he was going 42 miles an hour, and compared to the speed he was going to Los Angeles, which is 62, we know that he was going 20 miles an hour slower. So our correct answer is D. Now, this one's kind of a difficult one to understand because we also see that C is 20 miles an hour faster. So if you're thinking about it, he did drive 20 miles an hour faster to Los Angeles, but you have to listen to how the question is worded. It's worded, once again, it says, how did his speed on the way home, so on the way home was 42, and it says, compare to his speed on the way to Los Angeles. So we're comparing 42 to 62, and 42 is slower than 62 miles per hour. So that's why our correct answer is D and not C. Okay, 68 says the distance that a spring stretches when an object hangs from it varies directly with the weight of the object. If a spring stretches 2 centimeters when a 50-gram weight is attached to it, what is the weight of an object that stretches the same spring 5 centimeters? So here we have another spring question. So we know that a spring, 50 grams, will stretch a spring 2 centimeters. So now we're looking what the weight is when it stretches a spring 5 centimeters. So once again, we have to use common sense here. The weight is definitely going to be increased because it's stretching out more. So 20 grams is not going to be our answer. That's less than 50. The string should be stretched out a lot less than that. So let's go ahead and do the math here to figure this out. And once again, we're going to use our good old friend cross product to solve this. So for 2 centimeters, it stretches, it's 50 grams to stretch it that much. So how many grams, which is our question, is it going to take for it to stretch 5 centimeters? So we're going to go to multiply 50 by 5, which will give us 250. And we're going to go ahead and divide that by 2, which, we'll go ahead and do it in division box just so we get an accurate answer. 2 goes into 2 once. Drop the 5, into 5 twice, that's 4, and then into 10 5 times. So our answer is 125 grams, or C. As you can see, this is about the 3rd time in this test we use cross product. It is a great way to do it. All your comparison problems, especially when you're just missing one factor here. So go ahead and make sure you brush up on that and make sure you can do it so we can get some of these right. All right, 69 says a train traveled an average speed of 45 miles per hour for 2 hours and 30 miles per hour for 3 hours. What is the total number of miles that the train traveled? So we're looking for the total number of hours. So we know that the train traveled 45 miles an hour, which means in 1 hour it'll do 45 miles, and it was traveling at this speed for 2 hours, which means we're going to multiply it by 2. That will give us 90. So at that speed, it went 90 miles. It also traveled 30 miles an hour, which means in 1 hour, it traveled 30 miles for 3 hours. So I got to multiply that by 3, which will also give me 90 miles. And it's asking me, final question it's asking me is the total number of miles. So the total number of miles, if I add these up, is going to be 180 miles total that the train traveled at these 2 different speeds, which means my correct answer is C. All right, 70 says, how many millimeters are in 20 centimeters? Okay, we should be really good at this one. If you could remember your 7 blocks here, you know that your first block is kilo. I believe your second block is hecto. Your third block is deca. I believe that's what a K. Your fourth block is basic unit, which is just like meters in this case, meters. Your next block, 10 years, remember, is decade, so deci. 100 years is century, so centi. And 1,000 years is millennium, so milli. So here we go. We have 20 centimeters, so 20, always add your decimal point, centimeters. And we're converting it over to millimeters right here. So all we have to do is start at centimeters right here. Let me do it in a red marker so you can see it. Start at centimeters, and if we're turning centimeters to millimeters, all we have to do is travel there. So as you can see, it only takes us 1 step to get there, and it's to the right. So that means we're going to move this decimal point here 1 step to the right. We're going to fill the empty loop with a 0, which means 20 centimeters is equal to 200 millimeters, which means my correct answer is C. 71 says Mr. Craig made a scale drawing of his office. And as you can see, there's just a scale drawing. Not very detailed. It's very simple. The width of the scale drawing of his office is 2 inches. What is the actual width in feet of Mr. Craig's office? So as you can see, it is 2 feet right here. But that's just a scale drawing. As you can see, the key right here says that every ½ inch equals 3 feet. So how much is 2 inches? So it's pretty easy to do this. This is a problem we could easily do our head, because if we know ½ an inch is 3 feet in real life, then 1 inch is 6 feet and 2 inches is 12 feet. But as you know, I like to use cross product more than anyone, you probably know. So we're going to go ahead and use this for cross product. So we know that ½ an inch, which is 0.5 inches, is equal to 3 feet. I'll go ahead and label that so we don't lose track. And we know that the scale drawing is 2 inches, but we don't know how many actual feet that is. So 3 times 2 is 6, and 6 divided by 0.5. Oh, let's go ahead and do this one because this one's a good one. Good practice for division. As you know, our divisor cannot have a decimal point in it, so I'm going to move it over once. So now it's 5. And I'm going to move this decimal point over once because what I do the outside, I have to do the inside. 5 goes into 6 once. And 5 goes into 10 twice. So once again, my answer is 12. D is the correct answer. All right, last one for today. 72 says, Mr. Gray is planning to fly an airplane from Smithville to Sandia. So from here to here. As you can see, the key right here tells us that every inch on the map equals 40 miles. The distance from Smallville to Sandia measures 1.5 inches on the map. What is the actual distance from Smallville or Smithville to Sandia in miles? So here we go. Let's use cross product again. We know that 1 inch is 40 miles in real life, and we know that it's 1.5 inches away on the map, but we don't know how far that is. So 40 times 1.5 is going to give us 60, and 60 divided by 1 is 60. So x equals 60. My correct answer is C.